All right, boys and girls, just going to go through some topics quickly that you can look at over Thanksgiving break, and that should keep us on track and should help with not boring you during class with these simple concepts and tasks. So the first one is called the discriminant. Now, the discriminant is used only for informational purposes. We'll go through an example and hopefully that will help you understand what it is and what it actually does. So we all know the quadratic formula by now, hopefully. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we know a couple things already. We already know that the negative b over 2a is our axis of symmetry. So that we already know is part of our quadratic formula. Many people have asked me throughout the unit, we have to memorize these things, blah, blah, blah. Well, you shouldn't have to because you should use them enough. You should just know them. But if you have to go through and memorize it, I highly suggest you do. This, again, breaking up into pieces will help. So this negative b over 2a is the axis of symmetry. You should know that already, and that's part of your quadratic formula. The next piece is this right here. B squared minus 4ac. So b squared minus 4ac is what is called your discriminant. So that is your discriminant. Now, what does that do? Well, let's think. So let's say I do the discriminant of this first problem here. So b squared. So here, we'll do 2 squared. Then we'll do minus 4 a is 1. And then c is negative 24. So now if I add that together, I would get 4 minus, hold on, I have a visitor. Okay, sorry about that. All right, let's see. So 4 times 1 is 4. And then negative 24 times negative 4 is, let's see, 80, 96. So positive 96. Okay, and if I add this together, I get 100. So what does that mean? What does that tell us? We won't go over it just yet. Let's try the next one. So again, b squared. So now b is 3. So 3 squared minus 4a, again, is 1. C now is positive 7. C, 7. So now if I do the math, I get 9 minus 4 times 1 is 4. 4 times 7 is 28. So now for my discriminant, I get, let's see, is that negative 19? Okay, so what are these answers telling us? Why are we doing this? Take a minute, think about where the discriminant is located in our quadratic formula. Give me a couple more seconds. Awkward silence. Was that awkward? It was for me. Okay, so if this here is giving me the number that is under the square root, then it's going to tell me if my answers are going to be real or imaginary. If I get 100, I could take the square root of that number. That's possible. So I'm going to have a real solution. Now, how many unique real solutions will I have? Well, it's plus and minus. So I'm going to have 2 real solutions. Here, my answer is negative. So, will I have real solutions if what's under my square root is negative? No. Remember, if it's negative, that means it's going to be imaginary. So here, I will have 2 imaginary solutions. Because remember that square root of negative 19 is really I square root of 19. But when I ask for the discriminant, I don't want the square root part. I just want the numbers highlighted here in blue. That is what tells me, okay, positive, real solutions. Negative, imaginary solutions. And it's 2 of each. Now there's one more scenario that I will go over. So we'll do it again. B squared. So we got, boom. So negative 6 squared minus 4ac. And I'm going to get negative 6 squared is 36 minus 36 equals 0. What the heck? That's not really positive or negative. That's nothing. So let's think about what happens here. So if I break apart my quadratic formula into negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a, right? Because these common denominators allow us to write it as one fraction. But if this is 0, the square root of 0 is 0. So this would then be negative b over 2a plus or minus the square root of 0 is 0, 0 over 2a, which then would just kind of cancel everything out. So what does that actually mean? Well, I will still get an answer. It won't be imaginary. It's going to be real, but I'm only going to have one real solution. So what are these looking like for graphs? What does this mean? So here, 2 real solutions is any one of our normal quadratics. It'll look something either like this, where it's going through the x-axis twice going up, or something like this, where it's going through the x-axis twice going down. There are my 2 real solutions. Also here. That's what that looks like. What would the imaginary solutions look like? That's anything, any graph that doesn't touch the x-axis. So if it doesn't touch those are imaginary. And then finally, what about this last one? One real solution. Well, that's a case, for example, like this one here. If I factored this, it would be x minus 3 times x minus 3, because I'm multiplying to get positive 9 but adding to get negative 6. And when I solve for this, I would get x equals 3 and x equals 3. So that would be where the graph hits perfectly, where the vertex is perfectly on the x-axis. That's one real solution because you only have one number. So those are the scenarios. So the discriminant just gives us information. It just tells us, are we going to have real solutions? Are we going to have imaginary solutions? Or are we just going to have one real solution? So b squared minus 4ac is the discriminant. That's what you will need to know. Again, it's part of the quadratic formula, so it's just something that you should know already. Now you just have to apply it to what it means to a question. And a question would be like, given this function, does it have, or what type of solutions does it have? What types of solutions would be 2 real, 2 imaginary, 1 real? One of those options. I will attach some practice problems if you would like to try below and go from there. So again, hopefully that was straightforward enough and you can apply and try this out yourselves. Happy Thanksgiving. Hopefully you had your turkey already. And adios amigos.